So when we undo sine, cosine, tan, we have to remember that there's always two angle positions that have to be considered. Okay, so if I rotate this around, notice that this y positioning, which is sine, there's two different angle positions that always accompany a sine ratio. Okay, and it's to do with this it's across this y-axis. So the line of symmetry is going to be this y-axis. So I move that around. Doesn't matter where I put it. There's an equivalent y position or sine value for two different angles. So this sine value here gives me an angle position here and here. So there's always two positions. The same can be said with cos. So here's my cosine position. The cosine is my x positioning. Okay, so there's my x positioning for that angle. But there's also another angle up here. Okay, so the folding symmetry is across this line. And so if I move it around, doesn't matter where I move it, this x position here is mirrored over here. Okay, so this cosine ratio has two different positions here and here. Okay, so we always kind of think sine, this vertical line is my sine line of symmetry for sine positioning, or my y positioning. This x-axis is my line of symmetry for cosine positioning, or x positioning. Okay, so cosine is x, sine is y, so we have our line. Those also represent our lines of symmetry. Now it doesn't show it here, but the tan then is going to be my slope. So if I extend this line through, there's another position over here that is on the opposite side of the circle that represents the same slope positioning. Okay, so this position dot here, up here, gives me a certain slope, but the same position, different position down here would give me the same slope. Okay, so it doesn't matter where I put that, there's always going to be two positions on the circle that give me the same slope. So if I'm undoing tan, I also have to consider that there's two positions that same slope ratio can take up in the circle. Okay, so there's always a theta 1 and a theta 2 for sine, cos, and tan when we undo the sine, cos, and tan. And if we know the quadrant, we give one solution. If we don't know the quadrant, we give two solutions.